page 2, or at least your page 2. Number 13. The circle graph shows the results of a survey of 500 students who were asked to name their favorite season. Find the number of students who chose each season. Okay, you got a total group, and you always need to know what your total is if you're talking about a circle graph. So let's start with winter, and we know 25% of the group, which is the 500, like winter. Well, of means multiplication. 25% can be written as a fraction or a decimal. I'm going to do the decimal. And I'm going to come over here and do the arithmetic and take a little bit of advantage of doing 500. Move that zeros over, bring those down. 5 times 5 is 25. 2 times 5, 10 plus 2 is 12. And 2 decimal places. So 125 people like winter. Okay. We'll do the same thing with each one of them. So I've got 36% like summer. So 36% of the 500. So I'm going to go ahead and do it the same way. I'm going to do 0.36 times 500. We'll do the arithmetic under here. 0, 0, 30, 18, and your 2 decimal places. Put you 180 people for summer. So 125 people choose winter, 180 people choose summer. 22% is fall. So 22% as a decimal is 0.22. Of is times, so I'm going to go ahead and just do the multiplication. 0, 0, 10, carry 1, 11 with 2 decimal places. So 110 chose fall. And then the last one, 17% of the 500. So 17% is 0.17 of the 500. 0, 0, 35, 8, and 2 decimal places, and 85 people chose spring. And if you were to add these up, if you add up the 180 and the 110 and the 125 and the 85, it will add up to the 500 total people. Number 14, I'm going to come and solve it over here. So I'm going to write negative 4x plus 3y equals 12. And notice it says solve for y. That means we want to get our y by itself. Well, let's see what we need to get rid of. I have a 3 attached I'll have to get rid of, but I need to get rid of this minus 4x first. And to get rid of a minus 4x, let's add 4x. And we get 3y, this is gone, equals 12 plus 4x. Those are not like terms, I can't add them. I need to get rid of the 3. It's attached by multiplication. Let's divide. Divide both sides, the whole side by 3. 3's are gone, and you'll get y is equal to 12 plus 4x over 3. Now, I will add a little step. This is fine. There's nothing wrong with that. You can distribute that 3 if you care to go a little bit further. We'll be doing that a little bit later, some future lessons. You can distribute the 3 and go one more step and reduce it to 4 plus 4x over 3. Now, that is fine if you choose to do that. If you choose to do that, but leaving it as this right now is just great. No problem at all. Number 15, identify the domain and range of the function shown in the graph. It is a function. If you do the vertical line test, you'll notice that the x's do not repeat if you set up a t-table. So we're interested in, the domain is simply your x's, and your range is your y's, and those just go alphabetically. And the question is, what x's can I pick to put in as my input into my, if I was making a t-table. So I'm going to put d equals and put a little setback if they are sets. There's several ways of approaching it. You can look at I'd look at negatives, I'd look at 0, and I'd look at positives. Well, 1 has a y value, negative 2 has a y value, negative 3 would be down here, negative 4 has a y value down here, and every negative number is going to have a y value. 0 has a y value of 1, and then the values over here. 1/2 has a y value, 1 has a y value, and so on. So it ends up being all real numbers. And for right now, that's pretty much what happens, with a few exceptions, at the Algebra 1 level. The other way you can do it is take every point on the graph, and I probably should do that with a pencil if I have one handy, but if you drop every point back to the x-axis, if you just drop it straight back, you'll notice that there's not any point on this line that wouldn't be touched, so all real numbers. Now the range, if you pick these for the x's, then what are the y's going to be? Well, it's probably easier to do what we just said. Take it on the y-axis and start bringing these points back over and touching this y graph. And I'm just going to kind of shade it for you. See what I'm doing? Like this point comes over here, this point comes over here. And you'll notice as I do that, what's being touched on the y-axis is from here down. Well, that number is 1. And in the t-table, 0 does have a 1 value. So it is included in that. And then all of these numbers, 1/2, 0, all of these numbers. So the range ends up being all y's, this is your y-axis, that start at 1. So it can be equal to 1, but it's all the y's that are less than 1 also. Number 16, complete the table for y equals negative 9x plus 15. Well, we have 3 values for x, that's our input, and then we want to know what the y values would be that would come out. These are just ordered pairs is all they're being. So let's take y equals, let's put negative 5 in for x, and then put the plus 15 at the end. So let's do a little arithmetic. So we get positive 45 plus 15, which is 60. So when x is negative 5, y is 60. And that would be an ordered pair that you could graph on this graph, which actually is a line. Well, let's put a 1 in. Y equals negative 9 times 1 plus 15. That's negative 9 plus 15, and that's positive 6. So there's our y. And then the last one they want us to plug in is 3. Negative 9 times 3 plus 15 is negative 27 plus 15, which is negative 12 when you take 15 from that. Number 17. Number 17 says simplify, so we're looking for like terms. It's just an expression. It's got 4 terms, and we want to see if any are alike. Well, I see an 8m squared n squared, and I see a minus 6m squared n squared. So if you take 8 of these minus 6 of those, you get 2m squared n squared. So these are gone. And then we have a negative 7m squared n and a positive 5m squared n. Those are like terms. Well, negative 7 and positive 5 is a negative 2m squared n. Now, you can commute that, and you can put the negative 2m squared n in front of it, plus the 2m squared n squared. That's fine. That's not a multiplication. So let me do a little bit better job and rewrite that. 2m squared n squared. It's just where I did it in ink and wrote the wrong symbol, minus 2m squared n. So I'll just cover that one up. There's your correct answer. Just looked a little weird right there. Number 18, estimate the square root of 44 to the nearest integer. Well, your integers are, in this case, that's positive numbers. So we're looking for like 1, 2, 3, 4, 5, 6, 7, 8, and so on, that this would be closest to. Well, let's think about square roots. The square root of 25 is 5. And the square root, the next perfect square, is 6 squared. So the square root of 36 is 6. And then the next one, 7 squared, is the square root of 49. Well, 44 has got to fall somewhere in between these numbers, the square root of 44. So it's at 6 point something, but it says round to the nearest integer. Now we need to know, is it closer to 6 or 7? Well, 36 to 44 is going to be 8 away, but 44 to 49 is only 5 away. So notice it's closer to this one, so it's approximately 7. Okay, express the perimeter of the following rectangle in terms of n. Well, to find the perimeter of anything, you got to add up all 4 sides. So I've got 4n minus 9, and then I've got the other side of the rectangle, 4n minus 9, and I've got n plus 1, and the other side that's n plus 1. Well, I'm going to start right here. I'm going to put n plus 1 plus 4n minus 9. I'm just going around, plus n plus 1 plus 4n minus 9. And there's all my sides, 4 sides. Now these are 1n's, if you feel more comfortable doing that. So let's put our like terms together, very similar to what we did up here. 1n plus 4n is 5n, plus 1 is 6n, plus 4 more n's is 10n. So we can get rid of our n's. Okay, now let's look at our constants. 1 minus 9 plus negative 9 is negative 8, plus 1 would be negative 7, plus negative 9 would be negative 16. Number 20. Now, several ways you could do this. You could subtract the 1/15 and go about common denominators, but it's easier to get your common denominator early and then just solve it and get rid of the denominators, and then you don't have to worry about it through the rest of the problem. This was pretty simple, so you could do it several different ways. Well, the common denominator, the smallest common denominator of 15 and 6 and 1 is going to be 30. So let's get them all to 30. So I'm going to multiply this one by 30 over 30. I'm going to multiply this one by 2 over 2, and I'm going to multiply this one by 5 over 5. So I have 30x over 30 plus 2 over 30 is equal to 5 over 30. Now you can take every one of these terms, both sides, multiply by 30, and your denominators are gone. You have 30x plus 2 is equal to 5. Subtract 2. You get 30x is equal to 3. Divide by 30. Now be careful. Some of you reduce fractions. You have to be real careful as you're reducing that. Notice it's proper fraction. That's not 30 over 3. So divide by 3 over 3 and you get 1/10. You could write it as a decimal, 0.01. To me it's easy just to leave it as a fraction.